myself Sasan. Now I am going to explain about federated learning in data mining. Okay, let us go through it. Okay, introduction to federated learning in data mining. First thing, what is federated learning? So, federated learning is a new way of training AI that keeps data private and secure. So, like instead of collecting data in one place, different devices work together to improve the AI without sharing personal information. So, this method helps AI learn from many sources while keeping user data safe. So, next one is why federated learning. So, why we have to use federated learning? So, in normal machine learning, all data is collected in one central place, like a big server. Let us consider as a big server. This can create problems like privacy issues, security risk, and internet usage. So these are the some problems created when we use machine learning, normal machine learning. So to overcome this, we can use federated learning. So how we overcome by using this one? So instead of moving the data, federated learning trains the AI model where the data is stored. So this solves many problems like more privacy. Your data stays on your device only. So it is not shared. So your data is safe. So saves internet data. So only small updates are sent instead of a full data. This is one. And better AI model. It learns from many devices, makes it smarter and more useful. So let us consider a small example. Think about like this. Uh, how your phone's keyboard learns your typing style. Instead of sending all your messages to a company, it trains the model on your phone and only sends updates like not full data. So federated learning helps keep our data safe while still making AI smarter. So it is useful in it is useful. That is the reason why we use federated learning. Okay. So let us consider a mathematical approach. So in federated learning tries to minimize errors while training an AI model. So it does this by improving the model using data from multiple devices without sharing their actual data. So here we can see the formula. So here we can see FW. So it is like this is the error like loss function. So for the loss function from client. So here each client trains the model locally and calculates how wrong the model is. It can okay. Next is PK. So this is the importance. It is the importance of the weight of each client. Some clients may have more data, so they contribute more. And next one is W. So these are the this represent the model parameters that we are trying to improve. So what happened when we use this formula? So here each device trains the model locally using its own data. So the local results are sent to a central server only for the updates, not the data. So the central server combines all updates using the formula here above this one. So the AI model improves and it is sent back to the devices. So it helps the AI model without collecting user data. So it makes AI better by learning from different users. So this formula helps AI learn from many devices while keeping data private. So this is the federated learning importance. And so let us consider a small example. So here this is a small example question. So consider this scenario like we have five clients, different devices are users. Anything is okay. Okay. and each client has a different amount of data, like data set size, and each client trains the AI model locally and shared only the updated model, not the actual data. Okay. The server combines these updates based on how much data each client has. So let us observe this table. So here we can see local weight updates. So here each client trains the model and gets a new updated version. So here higher values mean the client's update is stronger. And the next one is data set size. So some clients have more data than others. So clients with more data contribute more to improving the AI model. So here and next one is contribution. So the server gives more importance to clients with larger data set. So here we can observe that here client 3, here the yeah, client 3 has the more data 1200 size, so it contributes the most, so it contributes 0.30. And client we can observe client 5, here client 5 is has least data like 500, so it contributes the least. So client trains the model locally and send only updates. The server combines these updates based on how much data each client has. So this way, federal learning trains a better AI model without collecting private data from users. Okay, so let us go through the calculations. So here we can calculating the global model. So how we calculate the global model? Just multiply the contribution and local weight updates. So here client 1 is contribution is 0.25 and local weight is 0.7. So here we are multiplying 0.25 into 0.7. So like this we are just multiplying the remaining clients and adding all clients. So and the total global model is 0.675. And here we can observe a pie chart also. So this pie chart represents larger the contribution, the bigger the section in the pie chart. So since we can say that client 3 has a higher contribution, so the its slice is the biggest. So uh, simply here client 1 contribution is 0.25. So just to we can convert this contribution this 0.25 into percentage, simply multiplying into 100. So we got 25 percentage, like that. Client 2 is 20 percentage, client 3 is 30, and client 4 is 15 percentage, and client 4 is 10 percentage. So here the highest percentage is client client 3, because the data size is 1200. So here we can observe that client item 3 is nothing but client 3 is 30 percentage. So this pie chart is visually represents how much each client influence the final model updates. So this is all about calculation the global model. And next one is applications of federated learning. So in federated learning is used in many fields to train AI models without sharing personal data. So there are some applications like healthcare, uh, and finance and edge devices and autonomous vehicles and smart assistants. So in healthcare, it helps train a model using data from many hospitals. So here keeps patient information private and secure. And the next one is finance. So in finance, banks use it to detect frauds. So and it can sensitive financial data is not shared with others. So like that, edge devices, like it is used to smartphones for futures features like predictive test, and it works without sending personal data to cloud servers. And next one is smart assistants. So in smart assistants, it can improve AI assistants like Google or Siri. So and it helps them learn better while protecting user privacy. And the next one is autonomous vehicles. So we can cars share learning from different locations, and it makes self-driving technology more accurate and safe. So in federated learning allows AI models to improve without any risking privacy. And these are the applications. And we can go through the advantages. So the advantages of federated learning is, it is privacy. So your data stays on your device only. So no need to send personal data to a server. So it is more secure. So and it is less data transfer. So reduce communication overhead. So instead of sending all the data, only model updates are shared. So this saves time and internet usage, and it works on many devices, simply scalability. So can be used on millions of devices at the same time. For example, many smartphones learning together now, like that. And the next one is it follows data protecting laws, it's nothing but compliance with the regulations. So it follows rules like GDPR, which protects user privacy, and it keeps data localized and safe. So these are the advantages by using federated learning. And like this we have some disadvantages also. So and these are the disadvantages. So while federated learning has many benefits, it also come with some challenges also, like data difference. Not all users have the same type of data. This can be make the AI model less accurate. And high device usage like computational overhead. So device need good processing power to train models. So older or weaker devices may struggle to keep up. And the one more disadvantage is slow updates. So in communication delay. Slow updates nothing but communication delay. So data from many devices must be combined. This can cause slow network performance. So we get like some delay, communication delay simply. And the next one is security risk. So hackers can try to change the model with the bad data. So if security is not strong, attacks can happen. So federated learning needs powerful devices and good security to work well. These are the disadvantages. So let us go. Let's finish this one with the conclusion. So federated learning is changing how we use data by allowing multiple people or organizations to work together without sharing their private data. So it is useful to many areas like healthcare, finance, and so on. So even though there are some challenges, new improvements in security and optimization are making in a strong alternative to traditional machine learning. So, as technical advances, federated learning will play an important role in building AI that protects privacy. Okay, and that's it. Thank you, for everyone. Thank you.